and relevant to what we're going to be talking about. Okay. Oh, I skipped a slide. Did I? Yeah. All right. Determine without graphing whether the function has a minimum or maximum value. Find the minimum or maximum value and determine where it occurs. Identify the function's domain and range when you're done. By the way, yesterday I guess we were supposed to find the domain and range for those problems, and I forgot to read that last step. Shame on me for not reading the directions. If you did that, fantastic. If you didn't, I forgot to mention it. We'll just do it in the section today. And if you did do it, thank you for doing it. And I'm sorry that I'm not going to make it required. But we'll just do it today. Okay. Max or min. You can tell whether it's going to have a minimum value or a maximum value based on what? What was that? Yeah. If it's negative, it's going to be downwards, and it's going to have a what? It's going to have a maximum, right? If it's positive, it's going to be going upwards, and therefore have a minimum. So let's just look at these and quick say what they're going to have, max or min. What's 39 going to have? A minimum, because it's positive parabola. Maximum, because it's a negative parabola. Minimum. So that part's done. Part A, min, max, min. Now, where is the minimum and maximum going to happen every time? At the vertex. They will always happen at the vertex. So, really, these are nothing more than what you've already done. Find the vertex. And that answers part B. That's where it's occurring. So let's just pick one of these and do it. 41. We know it has a maximum value. And we know what happens at the vertex, which is negative b over 2a, which gives me what? 1. Now we have to find the y value, so I'm going to plug 1 back in. That's negative 4 times 1 squared plus 8 times 1 minus 3. So that's negative 7 plus 8. Boom. There's part B. It's a max. Part A. Here's where it happens at part B. Now, you don't have to graph these to figure out the domain and range. What's the domain going to be for every one of these? All real numbers. Negative infinity to positive infinity. That thing's just going to keep going. So every single one of these is going to have a domain of negative infinity to positive infinity. The range, now think about this. Anything that has a maximum value is going to go from negative infinity up until that max. Anything with a minimum value is going to be the minimum to infinity. So which one is this? It's a max, so we're going to go from negative infinity up to what? 1, the y value. Negative infinity, oops, this needs a bracket, to 1 bracket. And if it were to have had a minimum, it would have been some number with a bracket to infinity. Before we move on, is there a specific aspect of that question, A, B, or C, that you'd like a little bit more clarification on? How we knew something, where I got a number, anything like that? Please ask if you need to. Okay, well, 39 and 43, is there one of those somebody would like to see? 39 or 43? One somebody would like to see? 43. First off, min or max? Minimum, right, because it's positive. So I'll do it right below in blue. It's going to have a minimum value. Where is that going to happen? At the vertex. Negative b. Now, you can add this in if it makes you feel better for that t value. Negative b over 2a. So that's 5 over 10, which reduces to 1/2. Plug that into the function for our y value. Ugh. You would give me another fraction. All right. Well, no problem. I'm going to kind of move that stuff down so I have more room to show this. All right. So I'm going to plug 1/2 into the function. 5 times 1/2 squared minus 5 times 1/2. Who can tell me what 1/2 squared is? 1/4. 1 half times 2 would be 1. So 5 times 1/4 is 5/4. 5 times 1 half is 5 halves. Common denominator. What do I need to do to this to make it over 4? Multiply it by 2. So that's 5/4 minus 10/4, which is negative 5/4. So here's the coordinate for our minimum value. And what would be my, well, domain is a no thinker. It's always going to be the same for these. What's my range? There you go. Oh, bracket. Negative 5/4 to infinity. Very good. We good? All right. Yeah. Yeah, anytime one of them is missing a term, feel free to add a 0 in there with it. As it turns out, since we didn't need the intercepts to see, we never, I don't think, ever needed it. But yeah, still a good thing to do. If you're missing a term, put in a 0 for it. All right. Ooh, we've already done all this. In 45 to 48, give the domain and range of each quadratic function that is described. So all we need is domain and range. Well, I'm not even going to look at these first before I put my domains on there. What's my domain? Yeah, all reals or negative to positive infinity. No parabola is going to be different than that. It would have to be a piecewise or something, which we're not working with today. Only thing we really have to worry about is the range. Oh, I don't want to do this yet. Okay, the vertex and the parabola opens up. Somebody raise your hand and tell me what that's telling us when it says the parabola opens up. Holly. That's right, it has a minimum value, which means my range is what? Negative 2 to infinity. If it opens up, then it has a bottom. So it's going to start at that bottom, negative 2, and just shoot upward. What about 47? The fact that it tells me that it has a maximum tells me what? Someone? That it's upside down. Right. Meaning the range would be, there you go, negative infinity to negative 6. It's kind of worded kind of funky there. It gave us x, then or y, whatever. Yeah, that's right. Awesome. Questions on that? All right, rock and roll. Here we go. 49 to 52. There's a lot of little bitty pieces to this section. Write an equation in standard form of the parabola that has the same shape as 2x squared, but with the given point as the vertex. Okay. No problem. Here we go. What is the equation for the vertex? Negative b over 2a. They're giving us a and b. Okay? All we have... No. They're giving us what this equals. This equals what for number 49? 5. This gives you the x coordinate of the vertex. Now, you know what a is. What is a? If they're all going to look like this, then they're all going to start with a 2x squared. What is a? 2. So that's negative b over 2 times 2 equals 5. And you have to solve for your b value. And then you're just going to plug it in. And that's it. You don't know the intercept. You don't know where it shifts. So that's why we're writing an equation, not the equation. We're only worried about the b value right now. So that's negative b over 4 equals 5. Multiply by 4. Move that negative over. And for this one, b equals negative 20, which makes my equation what? That's right, because it's negative b. Right. Yes. Sorry. Brain freeze. There we go. Yeah. Very good. Questions on that, about where any part of that came from. These are a tad tricky. I want you to try number 51. Try number 51 in your notes, then we'll compare it. I'll leave this up there as a reference. I'll come around if you have questions. Do that. Who's feeling confident? Oh, I might come back to you, but I already had you. Who's feeling confident? Come on. Come on, show. You are sort of? I guess that'll do. Yes, you do. Hold on. All right. Hit that 10 button in the top right, the little thing with the blue. What are you doing? I don't know. Click on the thing with the blue. All right. Just start working. There you go. All right. What's your question? Well, it's not a oh, I mean, yes, for these, because in the direction, what she covered up, it says that it's starting at 2x squared, which gave you an a value of 2. That's why it's there. And what is the equal? What is, all right, don't even think about that. What is negative b over 2x? Like, in last night somewhere, what did you do that? The export in the reverse, which is what you put. That's what it is. So you didn't want to include the 4 to 0 here? Yeah, well, it takes a long time to do this. This machine is the only place in the world I've better handwriting in my life. That's sure. Did I do that wrong in the last one? No, you did it right. Did I switch it on the last one? Well, when in doubt, here's the thing. Okay. I myself, remember who was I talking to earlier? I said those negatives are, yeah. I get lost in them too. When in doubt, just plug it back in and see if it gives you the right thing. If we left it at positive 40, that means if we were finding the vertex, we would make it negative 40, right? Would negative 40 over positive 4 give us negative 10? Yeah, so plus 40 is correct. You can always just go back and check it like that. Yeah, just stop right. Yeah, that's perfect. Did anybody have a question on that? Did anybody get something different they'd like for us to take a look at? All right, moving on then. Last slide. Told you, man, these first few chapters, they're lengthy sections. All right, write an equation in standard form of the parabola. So basically it's the same exact thing, except we have to figure out whether it's going to be positive or negative 3x squared, judging by what they gave us. So like the first one, if it's a maximum, does that mean it's going to go up or down? Down, which means which one of these is our a value? Positive or negative 3x squared? negative. And then from there, it's the exact same as the last problem because they still give you a vertex. They just worded it to you differently. What's our vertex on this problem? Negative 2, 4. Here's your a value. So negative b over 2a equals negative 2. And you're going to solve. It's exact same as the last problem. The only difference is you have to figure out which of these you're going to use depending on whether you're a max or a min. And they didn't give you the vertex in quite so obvious terms, but it's still there. Are there any questions about how we would go about work? It's going to work the exact same as the last slide. Would somebody like to see 53 or 55 worked out to its completion? And if so, which one? All right. Then this is what you should be turning in at the end of the day. You should have already had 2 through 38 done. So really, that's nothing more than 40 through 56 for most of you. Well, just a second. We'll take a poll. How about that?